Hi everyone, and welcome to Calendar Math with Miss Udoh. All right, guys, let's begin. Do you know what month it is? Let's think. It is the 5th month of the year. Last month was April, and next month will be June. So what month is it? Did you say May? If you did, you're absolutely correct. What day of the week is it? It is the first school day of the week. So what does that mean? That's right. Today is Monday. Well, if today is Monday, then what was yesterday? If today is Monday, that means that yesterday was Sunday. Well, if yesterday was Sunday and today is Monday, what will tomorrow be? You got it. Tomorrow will be Tuesday. Let's take a look at our calendar. Remember, our calendar assigns one number to every day of the month. Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. What comes after 17? Did you say 18? If you did, you're absolutely correct. Today is the 18th day of the month. Let's say our entire date together. Remember, we start with the day of the week, and then we say the month, the number, date, and then the year. Let's try it. Today is Monday, May 18th, 2020. One more time. Today is Monday, May 18th, 2020. Great job. All right, littles, we're going to do something just a little bit different today. Today, we are going to work with numbers greater than 10 to better understand place value. And we are going to do that by working in my candy shop. Now, in order to help me in my candy shop, there's a couple of things that you need to know. The first thing is that I sell candy in two different ways. I either sell candy by the box or I sell it by the piece. Can you take a look at that box on your screen and tell me how many candies are in a box? Did you say 10 candies? That's right. Every box has 10 pieces of candy. Now, if someone wants an amount of candies that is less than 10, they have to buy them as individual pieces, and they look like this. And so one piece of candy looks like the picture on your screen. And so people can either buy candies in a box or as single pieces. Can you help me put together this order? Let's take a look. Our first customer wants 3 boxes of candy and 6 pieces. Our job is to figure out how many candies our customer wants altogether. Well, let's start by getting his boxes. How many boxes does the customer want? That's right, 3 boxes. Let's count them out together. 1, 2, 3. Great job. Now, how many individual pieces of candy did our customer want? Did you say 6? That's right. So let's lay those out too. 1, 2, 3, 4, 5, 6. Great job. Now, what I need you to help me do is to figure out how many total pieces of candy our customer is buying. Well, let's start with our boxes. Do you remember how many pieces of candy are in each box? That's right, there are 10 pieces. Well, if we know that there are 10 pieces of candy in each box, how can we quickly count how many candies we have over here in all the boxes? Did you say count by tens? If you did, you're absolutely correct. Let's count by tens to find out how much candy is in the boxes. So our first box will be how much? That's right, 10. And if we're counting by tens, what's the next number? You got it, 20. And then we've got one more box, and that makes 30. Exactly. So in our boxes, we have 10, 20, 30 candies. Well, if we want to count individual pieces on the other side, those we count by ones. So after the number 30, what is the very next number that you get to? 30, 31. Exactly. Let's keep counting. 32, 33, 34, 35, 36. So how many candies is our customer buying in all? That's right, 36 candies. Great job, littles. All right, middles, it's your turn. We are still comparing fractions using visual models. Our problem of the day is to find a fraction with a denominator of 6 that is equivalent to a half. And we are still going to use our fraction strips like we did last week. So let's start with our first fraction. Our first fraction is a half. Before we do that though, what does the word equivalent mean? Did you say equal? If you did, you're absolutely correct. Well, how will we know that our fractions are equal or equivalent? We will know they're equal because both of our bars, when we use our fraction strips, will be the exact same length. All right, so now let's start with that half. Can you find the half on your fraction strip set? There it is. All right, let's move it to our board. Now, it said that we are going to compare with a fraction that has a denominator of 6. Which fraction strips are those? That's right, they're the 1/6 pieces, the ones in blue. And so we are trying to figure out how many 1/6 pieces are going to give us a fraction that is equivalent to a half. Let's start laying them out. 1, is that equal? No, it's not. 2, are we equal yet? Not quite. 3, are we equal now? Yes, we are. So this tells us that we need 3 1/6 pieces to make a fraction that's equal to a half. So 3/6 is equal to 1/2. Great job, middles. All right, senior scholars, here's your problem. This week, we are going to be multiplying using the area model. And our problem is 5 times 18. Let's begin by setting up our problem. Can any of our numbers be written in expanded form? Did you say 18? Great job. How do we write 18 in expanded form? That's right, 10 plus 8. So we're going to put 10 plus 8 at the top. And what are we going to put along our side? You guessed it, 5, because we are going to be multiplying 5 times 10 and 5 times 8 in order to figure out what 5 times 18 is. So let's begin. If I multiply 5 times 10, what do I get? That's right, I get 50. If I multiply 5 times 8, what do I get? You guessed it, 40. Whew, this is so simple. Well, what do I do next? Did you say add up your partial products? If you did, you're absolutely correct. So we're going to add 50 plus 40, and we will get 90. So this tells us that 5 times 18 equals 90. Great job, senior scholars. Thank you guys so much for tuning in to Calendar Math with Miss Udoh. I'll see you tomorrow. Bye.